Good afternoon. Today I am going to start function. So first of all, I am telling you the contents that we do in this area. Your contents are, your syllabus are, that is the function as a special kind of relation. Your contents are function as a, our objective is to learn the contents of function, and that is as follows: function as a special kind of relation. A special kind of relation. This is one relation from one set to another set. Pictorial representation of function, second point. Pictorial representation of function. The representation of function and domain codomain and range of the function real valued function, real valued function, domain and range of these functions, domain and range of these functions, constant, identity, polynomial functions, rational functions, and modulus function, modulus, signum, and greatest integer function, with their graph, with their graph. Some difference in product. Now, some difference and product. Some difference and product of the function. Product, division, etc. So these are the contents we are going to learn in this area. First of all, I am defining a function as a special kind of relation. These are the contents which we are doing. Our objective is to learn all these kind of things in this area. So first of all, I am going to define the function as a special kind of relation from one set to another set. So now, definition of function. A relation F from a non-empty set A to a non-empty set B is said to be function if number one, all the element of A is associated with element of B under F. Under F, I am working under my principle. Under F, so try to understand this concept. You are working under me. You are doing maths under me. I am working under my principle. So try to understand all the elements of A is associated with the element of B under F. Now second, each element of A is associated with one and only one element. One and only one element of B. That is, what does it mean? Our association is unique. Association is unique. First of all, you have understood the meaning of association. You are associated to your parents. You are associated to your teachers. There are two elements, teachers and you. You are associated with your teachers. You are associated to your parents, your family. So in this way, the association can be described. Association means related. In earlier chapter in relation, you have seen that ordered pair AB, elements A and B are related, associated. And if these two conditions are imposed between the relation of first and second element, in that case, that relation becomes function. So, F such that, in brief we say that, F such that A to B is called function. When, if each element of A is associated with element B under F. Under F. Now see. So this A is called the domain of this function. Domain of this function is A and codomain is B. Codomain is B. And now what about range? I am defining the range. Try to understand that. It is the subset of B. B means codomain. I am writing here. It is the subset of B containing, it is the subset of B, your range is the subset of B. Sometimes it is equal to B. Equal sets, a set equal to B is also subset of B. It is a subset of B containing image element, of the element of A. I have defined function, domain, codomain and range. A relation F such that when you have any doubt regarding function, you note my one sentence. I am writing here, driver knows the function of all parts of a vehicle. All parts of a vehicle. Whenever you have any doubt regarding the function, you note my one sentence, driver knows the function of all parts of a vehicle. When he operates a particular part of the vehicle, so the effect will comes out on the function. You have seen a polynomial function. Fx is equal to x square minus 3. When you find, how you find f3? So 3 is a part of the function. 3 is a part of this function. When you have taken your x part as 3, your result is 3 square minus 3, that is 9 minus 3 equals to 6. So driver knows the function of all parts of a vehicle. The same thing apply here. A relation F from a non-empty set A to a non-empty set B is said to be a function if all elements of A is associated with element of B under F. Each element of A is associated with one and only one element of B. That is, the association is unique, and in brief you can say that F says that A to B is called a function by satisfying the above the condition, and domain of this function is A, codomain is B, range it is defined as the subset of B, codomain containing image element of the element of A. Now I am showing it by pictorial diagram. How can you show your function by pictorial diagram? While testing, a given pictorial diagram represents a function or not, you have to test these two conditions which I have written here. If both the conditions are satisfied, then that given relation is a function. Now I am taking question. There are two parts of my question. Pictorial diagram. Set A, set B. Its elements are 1, 2, 3. This is set A, this is set B. Here is ABC. 1 is associated with A, 2 is associated with B, 3 is associated with C. Now, this is first. Second, this is your set A, this is your set B. This is 1, 2, 3. This is, here is two elements AB. 1 is associated with A, 2 and 3. This is second. Now third. This is A, this is B. Here is 1, 2, 3. A, B. 1 is associated with A, Put arrow on that. 2 is associated with B. This is third. Now fourth. This is A. This is B. A 1 2. Here A B C. One is associated with A. One is associated with B. And 2 is associated with C. This is fourth. This is the pictorial diagram of relations. You note that this is the pictorial diagram. Now I reach to second component of the function. First the function, and it is represented, function is represented by pictorial diagram, and that I have shown here. This is your first example. In order to show a given relation is a function when two conditions are satisfied, when all the elements of the domain A is associated, all the elements of the set A function as such that A to B is called a function. This called a function when if all the elements of set A must have the association. And second condition is this: the element of A is uniquely associated. They have one and only one association. So you have, in order to find out the given pictorial diagram represent a function or not, you have to find these two, you have to test these two conditions. You have to write, since all the elements of A is associated with the element of B, first condition is satisfied. There is no element left in A which have not the association. Means all the elements of A must have the association that is shown in this picture. So it means that first condition is satisfied. Now come to second condition. Each element have only one and only one image element. One and only one association. Image element means one and only one association. Means your association is unique. Your image element is unique. All the words we inform us the same thing. So all the elements of first condition is that all the elements of A must have the association, and the element second condition is and the element of A is uniquely associated. So what you can say about first? Your first is a function because both the conditions are satisfied. This is a function as such that A to B is a function because both the condition is satisfied. Now you come to second part. Here all the elements of the set A is associated. No element in A which is not associated with the element of B. Means first condition is satisfied. And now for second condition, one have a one and only one association. That is the unique association. Two have the unique association. And 3 is uniquely associated with B. Means this function, this relation is also a function. As such that A to B is a function. Because both the condition of function is satisfied. Now third, when I come to third, now you see, first condition is not satisfied. In this question, first condition is not satisfied because the element 3 of the set A not have the association with any element of B. It means first condition is not satisfied. Therefore, it is not a function. As such that A to B is not a function, because the element 3 of A has no association, has no association with any element of B, with any element of B. So that is the case. Similarly, now you see in this example, all the elements of A have the association, but the element 1 is not uniquely associated. Second condition is not satisfied. 1 is not uniquely associated because 1 have the association with A and B both. So it means that this is also not a function. Why this is not a function? You can write the condition also. So now I am coming to the first part again. As such that A to B, you have understood all the parts of that. Now what you can write? As such that A to B is a function because 1. All elements of A is associated with element of B. Element of B. Now second, what is the second condition? Elements of A is uniquely associated. Means the element of A has one and only one association. The element of A has one and only one association. One and only one association. You remember that. The same reason you can give for the second picture. And in third, if such that A to B is not a function, if such that A to B is not a function, this is for first and second both. Is not a function because number 1, because the element 3 of A, the element 3 of A has no association, with any element of B, with any element of B. This is the third. Now fourth. Fourth, if such that A to B, this relation is not a function because element 1 of A has more than one association. Has more than one association, and consequently it has not the unique association. It means this is not a function. That is the reason. So I hope you understood what I have told you. And again I am saying that if you have any confusion, repeating my sentence, regarding the function, driver knows the function of all parts of a vehicle. Now I am writing that a function f such that A to B. I am coming to that point. How this happened? A function f such that A to B if each y belongs to B, there exists some x belongs to A, and we can write y is equals to fx. X is the parts of the vehicle and f, that is operated by the driver. He knows to operate all the parts of the vehicle. X is the part of the vehicle and fx will give you the result, that is y. And if the driver wants to stop the vehicle, then that will be the y. Its speed becomes 0. Your vehicle is stopped there. If he wants to start, he wants to move, then he can operate that part of the vehicle and it can go. Similarly, that the same thing happened for the function also. Now I am taking another example. Now how can you define I have already defined domain, codomain and range. And one thing is the pre-image. If a function f such that a to b is defined by y equals to fx, if a function f such that a to b is defined by y is equals to fx, how can you define the pre-image? Image and pre-image. So when you find the value of x under f, the collection of y, collection of fx is the image. Your image is defined as all fx such that x belongs to A and y belongs to B, where y equals to fx. You remember this thing. This is the collection of image. How can you define pre-image? Your pre-image of y is x, image of x is y. Now I am writing here, image of x under f is y, and pre-image of y under f inverse is x. So that is the relationship between the image and pre-image. How we find the domain of the function? To find the domain of the function. Generally this question is asked in competitive exam also. To find the domain of a function. In order to find the domain of a function, what you are doing? Domain, first thing, remember, domain consists of all values of x for which fx is defined. And this criteria may differ from one function to another function. If the function is a polynomial function, it is a quadratic function. So quadratic function is defined for every real value of x. So therefore its domain is the set of real number. How you define set of real number? I have told you, set of real number is defined by minus infinity to infinity. When you say the function is real valued, if the domain of the function is either the set of real number or it is a subset of real number, then it is real valued function. So domain consists of all real values of x for which the function is defined. Second, if your function is given as a square root of certain expression, if your function is given as a square root of certain expression, your gx's expression. Gx's expression here. Then in this case, your fx is defined only when your gx is either equal to 0 or greater than 0. Because square root of negative real number is not defined, it is not real. So therefore, this function fx is defined only when your expression given inside the square root is either 0, you can find the square root of 0, it is 0, and you can find the square root of positive real number. So gx is greater than or equal to 0. If gx is greater than or equal to 0, then if this is greater than or equal to 0, then fx is defined. Fx is defined. Next point. And the collection of the set of all values of x for which fx is defined is the domain of the function. Set of values of x for which fx is defined is the domain of the function. This is the whole thing regarding this domain of the function. This is one point. Set of values of x for which fx is defined is the domain of the function. And from where this x comes? X comes from result 1. X comes from result 1. It comes from result 1. You remember that. Now, second thing is that rational function. How will you find the domain of rational function? A rational function, third point. A rational function Px is equals to fx by gx is defined only when gx is not equal to 0. The value of x for which gx is 0, the value of x for which gx is 0, that value of x does not present in the domain of the function. In domain of the function, you remember that. Domain of the function. Now, working rule to find the range of the function. Working rule to find the range of the function y is equals to fx. Your first step, step 1. In step 1, what you do, change the function y equals to fx. Change the function y is equals to fx as x equal to 5i. Step 2. Solve x is equal to fy and find the value of y. Is value of y. Set 3, step 3, the value of x the value of y obtained in step 2. The value of y obtained in step 2 is the value of x. Step 4, range of y equals to fx is those value of y. That is the step we proceed to find out the range of the function. Now, types of function and their graph. Now we are doing types of function and their graph. Type of function and their graph. First, constant function. You have seen if function y is equals to 2, y is equals to -4, fx equals to y equals to fx is the function, y is equals to fx is the function, fx is equal to 2, fx is equal to -4. Now you observe that your value of x is changes, but value of fx do not make any change. That is always constant. And the graph of such function, these functions are known as constant functions. If the variable x changes and the fx does not make any change in its value, then that function is known as the constant function, and their graph are parallel to x-axis. You see the graph of constant function. This is your x-axis, this is your y-axis. Fx is equals to 2. This is 1, this is 2. 1, 2, 3 and 4. -1, -2, -3, -4. Graph of fx equals to 2 is the graph of this function. It is parallel to x-axis. Fx equal to -4. F of -4 does not make any change as the value of x changes. So the graph of these two functions are parallel to, graph is parallel to x-axis at a distance of 2 units from origin. From origin, in case fx is equal to 2. Similarly, in case fx is equal to 2. So now you can say your this graph is above x-axis and your another graph is below x-axis. At a distance of 2 units from the origin, above x-axis. You add word above x-axis, one more word to define this clearly. Your graph of this function is parallel to x-axis at a distance of 2 units from the origin above the x-axis. In this case, in the case of fx is equal to 2. And in case of fx equal to minus 4, your graph is parallel to x-axis at a distance of 4 unit below the origin. In case fx is equal to minus 4. In general, what you can conclude? In general, f such that a to b defined as fx is equal to k is a constant function because as x changes, fx does not make any change. Does not make any change. So such functions are called constant function. You are using this constant anywhere. Now second function is identity function. Second, identity function. A function f such that R to R is known as identity function if fx equals to x. If you take y is equals to fx, so you can write this y equals to x. It means you get the equal values of x and fx. You get the equal value of x and fx. When you take x is equal to 1, then f1 is 1. If you take x is 2, then in case of x is 1, your implies f1 is 1. X is 2 implies f2 is 2. X is minus 2 implies f of minus 2 is minus 2. X is equal to minus 1 implies f of minus 1 is minus 1. So x and fx have the same value. So when you plot the graph of this identity function, you find your graph is as follows. This is x dash. This is your coordinate axis. This is 1, 2, 3. Minus 1, minus 2, minus 3. Y is 1, 2, 3. Minus 1, minus 2, minus 3. So you may say that the value of x fx, this is 1 f1. Both are 1 1. This is 1 1. 2 2. This is 2 2. This is minus 1 minus 1. This is minus 2 minus 2. When you join them, when you join these points, what you can say that? Your graph of identity function divides the first and third quadrant equally in two parts. You can notice one important point for this graph of the function. And Next one is a polynomial function. Third, polynomial function. A function f such that R to R defined by fx is equals to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus and so on plus a3x cube plus a2x square plus a1x plus a0, where a0, a1, a2 and so on, an are all real numbers. So this is called a polynomial function. If your polynomial function is of the form quadratic, cubic, biquadratic, then you can draw the graph of the function by taking points, by taking solution of the given polynomial function. If your polynomial function is given as fx equal to x square plus 3, you can draw the graph of that. By finding the solution of this, when x is 1, what is the value of f1? When x is minus 1, what is the value of f minus 1? You take the points, plot on the coordinate axis, and you join them. That is the graph of a polynomial function. So now next one is a rational function. In case of rational function, graph is not required. Rational function. A function as such that R to R, fourth, is a rational function. A function f such that R to R defined by fx is equals to px upon qx and qx is not equal to 0 is called a rational function. This is called rational function. This is called a rational function. Now next one is the modulus function, fifth. Modulus function. A function f such that R to R defined by fx is equals to mod x. It always assumes the positive value. Is called modulus function. Your fx is defined as x if x greater than 0, this is 0 if x equals to 0, this is minus x if x less than 0. Your domain of modulus function is set of real number. This is minus infinity to infinity, this is R, this is the set of real number. Set of real number in interval form you can write in this way, and your range is set of non-negative real number. Range is equals to 0 to infinity. This is also known as set of non-negative real numbers. Set of non-negative real numbers. Now the graph of modulus function. fx always have the positive value. In doing the graph of modulus function, you remember one thing, fx always reflect the positive value. This will help you. X, O, X dash, Y, O, Y dash. So when x is greater than 0, this is the part x is greater than 0, this is the part x less than 0. When x equal to 0, function is 0. So, and in both the parts, your fx assumes only positive value. Value of y is always positive. So graph is like that. You see, the graph goes like this. So this is the graph of modulus function. Next one, signum function. Your 6 is signum function. A function f such that R to R defined by fx is equals to 1 if x greater than 0, 0 if x equals to 0, this is minus 1 if x less than 0, is called signum function. Its domain is set of real number and its range is consists of only 3 elements minus 1, 0, 1. Now you see the graph of that. Graph of signum function. This is plus 1, this is minus 1, and this is the point 0. So what happens? When x is greater than 0, your fx is always 1. You may take x from 0 to infinity. You take x from 0 to infinity, but your graph is always shows the value 1. Your value of fx does not make any change as x changes from 0 to infinity. So in this part, your graph is parallel to x-axis at a distance of 1 unit from the origin above the x-axis. Now your fx is minus 1 when x is less than 0. So your graph is again parallel to x-axis in this part and at a distance of 1 unit from the origin below the x-axis. So you remember these things. So this is the graph of signum function, and if a function fx defined by this, then this is called signum function. So whenever you have any doubt, so you remember my one sentence. Driver knows the function of all parts of the vehicle. What is your parts? In the function y equals to fx, x is the part, different parts, and when f is operated on that, so you will get y as a product, fx as a product. So if anywhere any doubt regarding the function, you remember that. And again I am giving you some example to make it clear, because this is very confusing. And you also inform me about your learning procedure, and if there is any doubt, you tell me. Now I reach to algebra of real functions. Algebra of, second topic is algebra of real functions. In algebra, you know what happens? You are doing some operations, addition, subtraction, multiplication and division. So when I talk about algebra of real functions, we are doing all this kind of things. Algebra of real functions. Let f1 is a function from domain D1 to R. Here D1 is a subset of R. This I am taking real valued function. In all the cases, I am taking real valued function. D1 is a subset of R. A function f1 such that this is defined from D1 to R. Another function g is such that it is defined from D2 to R. D2 is also a subset of R. These two functions are real valued function because I am doing the algebra of real functions. So here D1 and D2 both are subset of real number, and of course your codomain is real number, so it is real valued function. So in algebra of real function, as I have told you, we are doing the operations of the function. Operations means addition, subtraction, multiplication and division. So your f plus g is a function defined from, f plus g is defined only in the intersection of d1 and d2. d1 is the domain of f, d2 is the domain of g. F plus g is defined in the intersection of d1 and d2. So your domain of f plus g is d1 intersection. I will write in that. So see that f plus g is defined such that defined from d1 intersection d2 is to r. This is the function, and you remember that your domain of this function, domain equals to d1 intersection d2, whereas d1 is the domain of f1 f and d2 is the domain of g. You remember this thing. Again I am repeating that. A function f says that d1 to r, g says that d2 to r. Here domain of f is d1, domain of g is d2, and when you are adding these two functions, when you are finding the addition of these two functions f plus g, so domain of f plus g is d1 intersection d2, and your this function f plus g is taken from in the common domain of f and g. So f plus g of x can be written as that is equals to fx plus gx. This is the addition of two functions. Now second, subtraction. F minus g is also a function which is defined from d1 intersection d2 to r. Again domain of f minus g is also d1 intersection d2, where d1 is the domain of f and d2 is the domain of g. Now this is first addition, this is second subtraction. F minus g of x, that is equals to fx minus gx. Third, multiplication. F into g is also a function from d1 intersection d2 to r. Your domain is again d1 intersection d2 for fg, for multiplication. So your f into g of x, your product is defined as fx into gx. Now fifth, this is third, this is fourth, division. F upon g such that d1 intersection d2 to r, and again domain is d1 intersection d2. d1 intersection d2, and f upon g of x is taken as fx divided by gx, and gx is not 0. So all this kind of things related to algebra of real functions. And now pictorial diagram. Again I am coming to pictorial diagram. You correlate all kind of these things which I have given you today in the following pictorial diagrams of the function. Number 1, let f represent weight, let f represent weight y belongs to B of a person, x belongs to A, such that f represents a function, f represents a function since each element of A corresponds exactly one element of B under F. Hence F such that A to B is a function. This is the conclusion about the function. And now you see, I have taken a set A. I am making one picture and you correlate with this. This is a set A and this is a set B. Here I have taken the members Amitabh Bachchan. Second is Abhishek. Third is Karishma. Fourth is Bhumika. And here their weights 75 kg, 68 kg, 47 kg and 52 kg, which I have given in this line. You see that. This is Amitabh Bachchan, his weight is 75 kg, you join them. Abhishek 68 kg, you join them. Karishma 47 kg, here you join them. Bhumika 52 kg. So now you see that, first of all, the things which is shown in this diagram from set A to B, I am making the relationship between the members given in A and their weights given in set B. So now you correlate that this pictorial diagram whether represents a function or not. First of all the persons given in the set A is associated with the element of B. And second condition, the weight of each member of A has one and only one weight. So the both condition of the function is satisfied over here. Therefore, this pictorial diagram represents the function. Therefore, f such that A to B is a function. This is a function. And domain of this function is Amitabh Bachchan and second Abhishek, Karishma and Bhumika. These are in the domain, and your range of this function, is 75 kg 68 kg, 47 kg and 52 kg. These, now in this case, you know that range is the subset of B containing the image element of A. In that case, that subset cover the whole set B, and your range of this function, range and codomain of this function, both are same in this case, in this example. Now, remaining thing I will discuss you next day. Thank you.